Okay, mathematicians, we are now on Unit 7, Lesson 4. And our focus for today, we have quite a bit to focus on today, but in general, we're going to generate, which means create, and extend numerical patterns, so number patterns, and we're going to identify relationships of corresponding terms. Some big words in our focus today, so let's make sure we understand what it is that we are trying to accomplish. Get that out of the way so you can copy that in your math notebooks. Okay, so generate means to create or make, and then we're going to extend. So we're going to make a pattern and then extend it further on to see how far we can go. And then we're also going to identify relationships. So we're going to look at how two numbers, corresponding terms, two different numbers, and what they have in common. Okay? So that's our focus for today. So when you're done writing your focus down, focus your eyes on page 245 in your student activity book, which you see on the board here as well. And it gives us some definitions. It says a numerical pattern is a sequence of numbers that share a relationship. So if I said 2, 4, 6, 8, 10, 12, 14, 16, what did you notice about those? All even. Okay, add by 2. All different types of relationships. That's a numerical pattern. Each number in a numerical pattern is a term. So when we talked over here about corresponding terms, a term is each number in a pattern. Okay, so below there are the first 5 terms of a pattern, 3, 5, 7, 9. And that pattern starts with 3, and then each term is 2 more than the previous term. Okay, so if you look underneath that, it says you can write numerical expressions for the terms. Could you scooch back? Thank you. Okay, so here we start with 3. And then we know we added 2 to every term. So here 3 plus 2 is our next one. Notice we have it as 3 plus 2 here, but it's also, okay, this is our next term. So we start with 3. This is our first term in the sequence, and we know we're adding by 2 each time. So notice this expression is starting with the number that we started with, and then the quantity of what number term we're doing by the increase in terms. Okay, so let's look at how that looks at the next one. So for 7, it could be 3, our starting term, plus 2 plus 2. Or we have 3, our starting term, plus the quantity of the number of term this is in the sequence. This is sequence 1, this is term 2. Okay, and we're multiplying it by 2 because we're adding 2 each time. Coming over here to 9, start with our starting term. And then we add 2, add 2, add 2. So we're adding 2 3 different times. So we're taking that, and that's where that 3 comes from because it's the third term in our sequence. Okay. And then finally, here's 11. Start with our starting term. And we added 2, add 2, add 2, add 2. So we either add 2 4 times or we multiply 2 by the quantity of 4 because it's the fourth number in our term. Okay, so let's look at some examples of that. Let's look at number 1. Let me scroll down a bit so we can see it a little better. It says write 2 expressions for the next term, the 6th term in the pattern. Okay, so here's 4 terms that we have. Or 5 terms that we have. We want to write the 6th term. Okay, so if we think about it, we add 2, add 2, add 2, add 2, add 2. How many times did we add 2? 3, 4, 5. Okay, so we took our original number, our starting term, and we added 2 5 times. Could we do 5 times 2 as well? Yep, that's how they did these. So either way, because multiplication is commutative. It could go either way. So that's one expression we could write. What's another one that we could write? We can take this and expand it. We can do 3 and then add 2 5 times. 1, 2, 3, 4, 5. Either expression will get you to the 6th term in this sequence, which is going to be 13. So write the next term. Let's look how it would solve. 2 times 5 is 10. 3 plus 10 is, so our next term would be 13. Okay. Go ahead and look at number 4. We're going to skip to number 4. So look at number 4. It says write the first 5 terms of a pattern that begins with 2 and then adds 2. Okay, so we want to begin with 2 and we're going to add 2 each time. So go ahead and fill in that pattern. Then part B says write the first 5 terms of a pattern that begins with 4 and adds 4 each time. So let's write that pattern. Now here's where we're going to look at the relationship between 2 corresponding terms. Okay, so if you notice in C, it says circle the corresponding pairs of terms in the pattern. Corresponding means the same number term. So that's term 1, term 2, term 3, term 4, term 5. Okay, so we circled the corresponding terms in the patterns. How does each term in the top pattern compare to the corresponding term in the bottom pattern? So we're comparing 2 to 4, 4 to 8, 6 to 12, 8 to 16, and 10 to 20. Turn and talk. How does that compare? 1. All right, so what I heard a lot of is it's times 2. We take 2 times 2 and get 4, 4 times 2 and get 8, 6 times 2 and get 12, 8 times 2 and get 16, 10 times 2 and get 20. So for this line, the top term is the bottom term divided by 2. Or you could say the bottom term is the top term multiplied by 2. For D, how does the bottom term compare to the top term? So here, this would be the opposite of that. The bottom term is the top term times 2. So the bottom term is the top term multiplied by 2. So that's looking at corresponding terms and comparing them and finding that relationship, which is one of our focuses for today. Okay. Another part of our focus was creating or generating and extending patterns and numbers. So let's look at that. Let's look at number 7. So it says many situations in your everyday life can be described by numerical patterns. The table below shows late fees for an overdue library book. Complete the table. Okay, so number of days late would be the term number here. Late fee would be the actual terms. So we have a pattern here. 15 cents on day 1, day 2 it's 30 cents. So describe the relationship between the corresponding terms. Here's our corresponding terms, 15 cents and 30 cents. What's the relationship between those? Turn and talk. 0. Okay, I heard a couple different choices. Some people said you add 15 cents each day. Totally true. Other people said you take the day and you multiply it by 15. Is that true as well? Yes. So either one is true. So the late fees in cents is the number of days late multiplied by 15, or it adds 15 cents each day. Okay, so again, we're looking at the corresponding patterns between the terms. Okay, looking at page 248, here's another way to look at corresponding terms. We're looking at prime and composite numbers. So first, let's identify what a prime number is. Okay, it tells us right here a prime number is a number greater than 1 that has 1 and itself as the only factors. So only factors are 1 and whatever the number is. So we could use X to fill that in if we want to. We need to know what a factor is in order to understand this definition. Okay, so remember a factor is one of the numbers in a multiplication problem. Okay, so for factors, let's look at all the one-digit numbers. I'm looking at number 1 right now, right? All the one-digit numbers that are prime. Okay, so 2 is a prime number. You can only evenly divide it by 1 in itself. Okay, those are the only ways you can multiply two numbers. 1 times 2 is the only way you can get to 2. 3, 5, and 7 are all prime numbers that only have one digit. If you look at number 2, it says write all the two-digit numbers less than 20 that are prime. Okay, so 11, 13, 17, and 19 are all prime. So we're going to use that information to try numbers 3 and 6. It says write an expression for the number using prime factors. So we're going to only use these numbers as factors, multiply them together to create the number 8. What are the only factors that we can use to create 8? We'd have to take 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. It's the only way we could get to 8. I'm sorry. Yeah, that's it. Okay, look at number 6. With 30, well, I know 30 is divisible by 5. 5 times 6 equals 30. How can I create 6? 2 times 3. So it would be 2 times 3 times 5, because 2 times 3 is 6, and then 6 times 5 would get me to 30. Okay, so these expressions will get me to that number that is there. Okay, so real quick at the bottom here, numbers 12 through 17, it's asking you to tell if a number is prime or composite. So we need to know what it means to be composite. Okay, basically composite and prime are opposites. So composite means that it's not prime. Okay, which means it can be multiplied by more than 1 and itself. Okay, so for example, 36, which is a number 13. Number 13 is 36. That's a composite number because it can be divided by 12, it could be divided by 2, it could be divided by 6. Lots of numbers can evenly divide or be multiplied together to get 36. Okay, so that is a composite number. However, the number 29, the only numbers that we can evenly divide 29 by are 1 and 29, which makes it prime. Okay. So we've now looked at relationships between terms. We've looked at expanding patterns and numbers, and then we've also touched on prime and composite numbers. So we'll be using all of that next week on Monday.